So, hello everyone again and welcome to my channel. So today I'm going to be talking about something quite interesting, and this is kind of the origin story of organic chemistry and the brain behind organic chemistry. So from the last or the previous video, we talked about something quite interesting. We said that not all carbon atoms will generate organic compounds, but now we're going to look at a specific subject which is called atom, because this is going to be a review section of what atom really means and what they are actually made up of. So this part here, we're going to look at the structure of an atom and isotope. So in this case here, what do we know about an atom? We do know that the structure of an atom is quite related to the number of protons it has alongside the number of neutrons and the number of electrons. Now all these three components makes up an atom, and what's quite interesting is that there's kind of a check and balance in this particular structure, which makes an atom a neutral structure in general. So what do we know about a proton? A proton is meant to have a positive charge on it, and neutrons are quite to be neutral. In this case, you see, neutral, neutron, neutral, neutral. Just a quick reminder. And electrons are negatively charged. That is one of the things that makes these guys to be quite unique in a way. Now, the interesting thing about it is that for a proton, we need to know that these protons gives the identity of a particular atom. Like for example, you look at the periodic table, you see all these numerous elements, and the only thing that makes them really unique is the number of protons that are actually in the nucleus, because we know that the nucleus is actually the combination of the proton and also the neutrons. But overall, the nucleus is still a positive charged region, and surrounding the nucleus is actually a sea of little particles known as the electrons over here. Now these little electrons over here are actually in a space of surrounding the nucleus. And what's quite unique in this case is that there is kind of an equal in the number of protons versus the number of electrons, which makes them to be overall neutral for that particular atom over here. So in this case here, we do know that elements are distinguished in terms of this particular number of protons over here. And one of the unique things about protons and versus electrons is that 100 or 1800 times the mass of electrons gives us the number of proton, which tells us how huge or massive the mass of the nucleus is versus the electrons that are surrounding this particular nucleus. And in this case now, we do know that the electrons involved are mostly involved in chemical reactions and also chemical bonding. So those are mainly the most important thing you need to know about electrons, and how electrons will be involved in organic chemistry hugely or mostly in this particular case. And now we do know that atoms, of course, of similar proton number but different neutron number in some cases are called isotopes. So in this case now, subject here, we'll talk about isotopes, and isotopes which focuses on the same proton number but differences in the neutron number. And a huge example of this particular case is carbon. Since we are going to use carbon, because carbon is involved in organic chemistry, we're going to focus more on carbon. Now, we do know that most organic reactions are mostly involved using carbon-12. And why do I say carbon-12? Carbon-12 is hugely popular because it's the most abundant carbon in nature, 1, and 2, we don't know that the structure involves 6 protons and 6 neutrons. Now, this gives a different mass composition of carbon-12 versus including another kind of closely related to carbon-12, which is carbon-13. Carbon-13 has 6 protons, just put PS for 6 protons, but in this case it has 7 neutral species, which are called neutrons overall. That is it. And this particular carbon species, which is an isotope of carbon, is known to have about 1% in terms of the overall composition of carbon isotopes in nature. And last and foremost, which is really important isotope, is carbon-14. And carbon-14 has 6 protons, of course, but in this case has 8 neutrons in the nucleus. And one of the reasons why carbon-14 is really important is because of its radioactivity. Is really radioactive, and this radioactivity makes it to have a really huge half-life of 5,730 years. Quite a huge gap, fantastic gap. And this huge gap timeline in terms of its half-life makes it really popular in terms of analyzing various organic compounds that have existed really in the thousands of years. So by that way, we can know when this species or organism existed and how this species has actually evolved over the past couple of years overall. So pretty much the timeline that usually target out is between or around 5 or 50,000 years old till the present timing over here. So that is about it overall for isotopes and also the principles of atomic structure, part 1, involving the structure of an atom. Anyways guys, thanks for watching my video. You can check other videos right now, and also please don't forget to hit the like button, share and subscribe. Have a good day guys. Peace. Love you all. Bye. All these are all the different colors representing different bonds and also different hybridizations that you want to make for specific compounds over here.